We are talking about numbers. Okay, so what are numbers? Everything which you do in maths is this way or the other related to numbers, right? We know that 1 is a number 1 by 2 is a number, 10 by 2 is a number, 10 is a number, right? So all these are numbers. But in maths we classify numbers. How? I'll tell you. Let's talk about real numbers. Real numbers. Okay, real numbers is the first topic. What are real numbers? Okay, so at your level you can think of a real number as every number in maths. Okay, so every number in maths is a real number. Okay, now I'll tell you, although in maths we do have other kind as well, but at your level you should know every number which we talk about. Let's say it is -10, let's say it's -5, maybe it's -1 by 2, even if it's 0, if it is 0.5, if it is 10, if it is 10, 0, 0, 0. Every number at your level in maths is a real number, even if it is negative, even if it is 0, even if it's a fraction, even if it is decimal number, right? So real number is a big branch. Okay, in real numbers we have all the negative numbers, we have 0. We have all the positive numbers, we have fractions, we have fractions, we have decimals, right? All these numbers in maths are real numbers, so we write the set as this r equals these 3 dots, means that we have all the negative numbers and maths in the set of real numbers, right? I cannot write every number, so we denote it by 3 dots, and again I have 3 dots because I have all the positive numbers in maths as well, which I cannot describe now, so I'm just using 3 dots, right? So is this thing clear so far? Then what are real numbers? So let's talk about this. Was the first set. Let's talk about the second set. That is, in this is basically the set of natural numbers, right? Okay, now what are natural numbers? It is very easy, I'll tell you. It starts off with 1, then we have 2, 3, 4, and so on. Okay, so in natural numbers we have all the positive whole numbers, right? Except 0. Okay, in natural numbers we do not have 0. The set of natural number is starting with 1, and in natural numbers we do not have any fractions, any decimal numbers. No, we only have positive whole numbers. We have 1, 2, 3, 4, 5, so on till infinity. By infinity I mean that we cannot count numbers and maths, they are going on continuously, so the last symbol is when max is said to be infinity, right? So every positive whole number is a natural number. Alright, then if I talk about the set of integers, I denote it with z, and we have -3, -2, -1, 0, 1, 2, 3, and so on. Okay, so in integers again we have whole numbers, we do not have any decimal numbers, any fractions, but we have 0, and we have all the negative and positive whole numbers and 0 as well. Okay, so this is how we define the set of integers. Here I am not saying positive integers or negative integers, here I am saying just integers. When I say just integers, I have 0. I have negative integers and I have positive integers. Right now if I talk about the set of positive integers, here I'm going to have 1, 2, 3, and so on. All the positive whole numbers, just like the set of natural numbers. Right, is this thing clear? A possible question like in national numbers that accept 0 at all the positive numbers positive whole numbers, so why isn't 0 because 0 is not included in natural numbers. Like this is how we define sets in maths. Answer : we don't write decimal numbers just like we don't write fractions. We do not include 0 in the set of natural numbers, and yes, in some books you will find that 0 is part of the set of natural numbers. In fact, in Google as well you will find many definitions where 0 is a set of natural numbers, but actually we do not have 0 in set of natural numbers. Why? Because this is how we define this set. Okay, this is how we define it. We do not have negative integers as well in natural numbers because we are classifying different sets whatever way we want to in math. Okay, like I am not doing it on my own. This is how mathematicians have defined it: integers that complete the answer. Let's talk about the fifth type, that is negative integers. So can anyone tell me what am I going to get in this step? Negative numbers. Very good, so I will get except 0. I will not include 0 all the negative whole numbers, right? So I will have -1, -2, -3 and so on. Okay, so we are done with this. Yes. Do we have fractions and decimals and integers? No, 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 we only have whole numbers. Okay, we have positive and negative whole numbers and 0. Okay, so in integers we have negative whole numbers, we have 0, we have positive whole numbers. If we talk about positive integers particularly, I will only have positive whole numbers just like I have in natural numbers. And if I talk about the set of negative integers, this one z minus I will only have negative whole numbers, right? So is this thing clear so far? Yes, alright. Okay, so let me just clear all this and talk about another thing. Factors, multiples. Factors and multiples. Okay, now when we talk about factors, what is a factor? Let's just define it first. Factor divides a number completely without leaving any remainder. Okay, we will talk about this definition in detail, right? So here the definition says that factor divides a number completely without leaving any remainder. Now what do they mean? Okay, so factors are basically numbers which when we divide by a number, we get 0 remainder. By this I mean, for example, if I'm interested in finding the factors of 9, okay, so in this case every number that divides 9 completely, factor divides a number. In this case I have 9 factors divides a number that is 9 completely without leaving any remainder. Okay, so in this case I have 9 in definition. Obviously we talk about things generally, so factors of 9 would be, so I have 9 divided by 1 gives me 9, remainder would be 0. Yes, anyone? What about other factors? So 1 is a factor, 10, 3, 3, very good, and then 9, it says very well done. Okay, so we only have these 3 factors. Okay, and if we talk about the factors of 11, so we have 1 and 11 itself, very good, 1 and 11. Okay, and now if I talk about multiples here, a multiple is the result of multiplying a number by an integer, right? So if I talk about the multiples of 9, so that would be 9 into 1 is 9, 9 2 is 18. 9 into 3 is 27, 9 into 4 is 36. And so on, right? So are you guys clear with factors and multiples? We need to talk about trying numbers now. Are you guys familiar with what a prime number is? Yes, okay, so what is the prime number? It has only it can be divisible by itself and by 1. Very good, very good. Okay, excellent. So if we talk about the definition, prime number is a natural number greater than 1, which is divisible by 1 and the number itself. Okay, now this is the reflection of a prime number, that it is a natural number, which means that what are natural numbers? A quick recall: 1, 2, 3 and so on, all the positive whole numbers. So a prime number would be a positive whole number that is greater than 1. Okay, we know that 1 is divisible by 1 and obviously itself as well, so one might think that 1 is a prime number, but no, 1 is not a prank number. Okay, be very careful. The students mess up with this part every time because they say that 1 is divisible by 1 and itself as well. It is a number. No, prime number is a natural number. That means it is any positive whole number that is greater than 1, which is divisible by 1 and the number itself. Okay, so instead of natural numbers we have 2. We have this 2. Let's talk about this 2. Now 2 is divisible by 1. We get remainder 0, and 2 is divisible by 2, so these are the only two numbers, 1 and 2, with which 2 is the divisible, right? So this means that 2 would be a prime number. Okay, so if we talk about examples, 2 is a prime number. Let's talk about 4. Okay, so I can divide 4 by 1, yes. And I can divide 4 by 4, obviously that is obvious, but I can divide 4 by 2 as well. When I divide 4 by 2 I get 0 remainder, which means that 2 is also a factor. So prime number has only 2 factors, 1 and number itself. In case of 4, we have 1, 2 and 4. We have 3 factors, so 4 cannot be a prime number, right? So 2 is a prime number, 3 is a prime number, 7 is a prime number. So is this thing. Yes, very good, excellent. Okay, perfect. So we are done with this thing as well, right? So let's see next topic. Okay, now we have to talk about. Now we have a very simple topic. Let's just do it quickly. Common factors. We have common factors and common multiples, right? So this is the next topic. Now we have two numbers. Let's say we have 16 and 24. And you are interested in knowing the common factors. It's quite self-explanatory. Common factors, you'll write down the factors of both these numbers and we'll find out the common ones. Okay, so if you talk about the factors of 16, can you tell me the factors of 16? 16 for 1, 16. Okay, 1. Let's try to do it in order. Okay, 1 for 16, yes, and 2, right, because 16 divided by 2 is 8, remainder is 0. And 8 as well. Okay, because another way of doing it, you know that 2 into 8 is 16, so this means that 8 into 2 would be 16 as well, right? If this is a factor, this would also be a factor, so you can directly write it down. Okay, so this is how we do it. Okay, so very good, these are the factors of 16 and so name give me the factors of 24. 2 yes but 1 okay, start off with 1 always 1 2 yes very good then. 4 okay 4 and 3 as well okay we have 3 as well. 8 into 3 is 24 so we have 1 we have 2 we have 3 we have 4 then okay now I'll tell you a quick thing now obviously. Whenever finding factors is not difficult but it is time taking so we don't have that much time what we would. You have to do is now you know that 2 is a factor of 24 but 2 into what is 24 2 into 12 is 24 okay now you know that 3 is a factor of 24 so 3 into what is 24 3 into 8 is 24 right now you know that 4 is a factor of 24 but 4 into what is 24 yes any 4 into 6 okay so now this means that 12 8 and 6 these are also the factors okay so you can just note them down directly and finally 24 to 24 so one thing is given. Every number has at least two factors right 1 and the number itself 16 was the number so 1 is a factor certainly and number itself is a factor certainly. If we talk about 24 1 is a factor and the number itself is a factor now all these internal factors are going to come by thinking and you know by hitting trial method but an easy approach of doing this is if you know that 2 is a factor think of the other number think of the number with which when you multiply 2 you'll get 24. Think of the number with which when you multiply 3 you will get 24 right and then you will get to know about the other factors as well okay is this thing clear? Yes ma'am okay alright so I repeat you guys can ask me multiple times I don't mind questions okay just stop me here and then and ask me. Okay so the topic was to find out the common factors right so obviously 1 is common. 1 would be common in every number then 2 is common. Then we had 4 here as well when I wrapped the other things 4 was also loved. So 4 is also a factor then 8 is also a factor right so. Here we are not finding HCF for stuff like that no we are just talking about the common factors so these are the common factors 1 2 4 and 8 right these are the common factors right. Now if we talk about the common multiples of let's say 3 and 9 now when we talk about multiples there should be a limit because multiples of 3 are 3 9 sorry 3. Then we have 6 9 12 15 18 21 and so on right when we talk about multiples we don't have 2 multiples or 3 multiples we have infinite many multiples of every number in max right. So this means that whenever you will come across such a question where they want you to find common multiples they will mention it this way common multiples of 3 and 9 till let's say 21 okay right so for 3 we have listed for 9 let's do it we have 9 1 9 into 1 is 9. 9 into 2 is 18 and then when we do 9 into 3 we get 27 right 27 is greater than 21 so there's no point in listing this now when we talk about the common ones. We have very good excellent okay so we have 9 and 18 only so 9 and 18 are common multiples okay so any questions so For anything which is confusing you guys, any questions from the previous topics which we have discussed? Nobody? No. Alright, very good. Okay, now the next topic is a bit different. I won't say it is difficult, it is a bit different. Okay, so let's talk about it. Alright, so we have terminating decimals, terminating decimals, and we have a none terminating decimals. Alright. Okay. So if we talk about this topic, when we have terminating decimals, terminating means ending, stopping. It is a word of that type. Okay, so we will have, for example, 0.675. We will have 0.05. We will have 0.125. We will have 0. Okay, all these are examples of terminating decimals. When I say terminating decimals, I mean any number which has decimal and there's a stop after the decimal. Okay, so we have three numbers of the decimal, we have two numbers after the decimal, we have three numbers after the decimal, we have four numbers after the decimal. But if I talk about non-terminating, it means that the number is going on continuously after the decimal and it's not stopping. Okay, this means that this is a non-terminating decimal even if you do it on your calculator. When you find the value of pi, it is 3.1415292, etc., something of this type. Right, so although it looks like that it is 1 2 3 4 5 6 7 8, it looks like it is 7 decimal places or 8 decimal places, but it is not like that on your calculators. There is a limit, they cannot display further numbers, so we do have such numbers as well which are not stopping after the decimal. Okay, they are going on content, you see, and pi is an example in front of you. So such numbers are non-terminating decimals, and such numbers with decimal where this limit after the decimal, they are stopping after some decimal places, even if it is 10. Even if the number is of this type 90.0012567894, but at least that's stopping, so it would still be a terminating decimal. But if the number is not stopping like this one or this one, it would be non-terminating, right? So is this thing clear? Now if I talk about another branch which is related to this topic, I'll write it here. It is recurring and non-recurring. Right, by recurring it means the number which is coming after decimal is being repeated. Right, okay, now in this case 0.31, now this 31 is being repeated again and again, so I can write down this number like this, 0.31 with a dash on it. Okay, I'll rub all the other batches because it might confuse you. Okay, so it is 0.31 with a dash. Okay, let's say if it is 0.142142142, now I can see that 142 is being repeated, right? So I can write it as 0.142 with a dash on it. So what is this? Recurring decimals and non-recurring decimals. Recurring means repeating. Okay, repeating decimals, that's quite self-explanatory. After the decimal, the number which we are getting, forget about if it is terminating or non-terminating. We are not discussing that RG moment. The only thing which we are discussing here is if the number after the decimal is being repeated. Now this number is being repeated after every 2 digits 3 1 then. We have 3 1 then again we have 3 1 and here in this case it is being repeated. After every 3 digits write 142 142 142 so we can write it with a dash on top. Okay, so this is what recurring decimals are, and when we talk about non-recurring, it is of this type 0.78941169. You know all these numbers. 0.71 etc. Okay, so all these numbers are non-recurring decimal. That could be that it is a terminating decimal like 0.675. 42 at least it's stopping, it's still terminating, but forget about terminating and non-terminating here. Okay, we are not discussing that here, don't get confused with that part, sorry. We have 4 things, so one is terminating. Terminating means the number after the decimal is stopping. 0.65 it's stopping. After 3 decimal places it's stopping. After again 3 decimal places it's stopping. After 2 decimal places it's stopping. After 4 decimal places, if we talk about non-terminating, it is not stopping up after. You know, even after infinite many decimal places, okay, it's going on continuously like this. Okay, we have an example pi. Then in recording we are saying even if it is in, even if the number is stopping after some decimal places, or it is not. The only thing which we are interested in is knowing that after the decimal the number is repeated. 31313 10.142.0.142.142.142 is being repeated. Okay. And in non-recurring it is not being repeated. Okay, there's not a fixed pattern, the numbers are not appearing. So let's talk about, okay, then these definitions are needed, and we will define the last set for today, that is rational and irrational numbers. Rational numbers. Rational numbers. Okay. A number that can be written in the form of by b, where a and b are integers, or if it is a terminating decimal number, or if it is recurring decimal. Okay, now just like natural numbers, just like positive natural, or just like integers, just like positive integers, negative integers, we have another set of rational numbers in maths, right? So what is the definition? Saying a number that can be written in the form of by b, where a and b are integers. It looks complicated, but it is very simple. Just like 1 by 2, 1 is an integer, 2 is an integer, just like 5 by 6, 5 and 6 are integers. So any fraction where in the numerator we have an integer, in the denominator we have an integer. By integer they are trying to say whole number, it is a rational number, right? Okay, now if it's not a fraction but terminating decimal number, like we have 0.675 or we have 0.05, since these are terminating decimal numbers, these are also rational numbers, right? Or recurring decimal. By recurring decimal they mean if we have 0.313131, something of this type, it is also a rational number, right? So far we know a rational number is a fraction, it is a terminating decimal, or it is a recurring decimal. Okay, so it could be that in MCQs you have been asked to choose a rational number and you have these following options. 1 is pi, then A is pi. Then B is 0.195, then C is 0.821, and then the option is, let's say, under root 2. Okay, now let's see, this is a question in the MCQ paper and you have to choose a rational number. Okay, now if you look at the restoration of rational numbers, we have either a number which is written in this form A by B, we cannot see any fractions in the options, so forget about this part, or terminating decimal. Yes, we have two decimal numbers, one is B and one is A. If one is C, in C the decimal is non-terminating because it is not stopping even after infinite main decimal places, but if we talk about B option, we only have 3 numbers after the decimal, so this means that it is a terminating decimal number. Right, so it would be a rational number, so B is the choice. Right, is this thing clear? Now we have to discuss the last topic for today, that is irrational numbers. Irrational numbers. Okay, so it is a number that cannot be written as a fraction like A by B, or it is a non-terminating decimal number, or it is a non-recurring decimal number. Okay. Alright, now we have the final thing for today, irrational numbers. So it is a number that cannot be written as a fraction A by B. It is opposite of a rational number. In case of rational numbers we have fractions, and here we do not have fractions, right? We have non-terminating decimal here, and rational numbers we have terminating decimal. And the last thing is we have non-recurring decimal numbers, and in rational numbers we have recurring decimal numbers. Okay, so let's talk about examples. Examples. Irrational numbers could be of the type 2.142967. 8. Since it is non-terminating, we have infinite many decimal places. It means that it is going to be an irrational number. Okay, so this is the first example. Then if I talk about the second example, we have pi, and why is pi an irrational number? Because I can write pi as 3.141592. Again, it is a non-terminating decimal, right? And in the last, whenever we have under root n and this n is a prime number. Just give me a second, please. Okay. Or any non-perfect square. This would also be an irrational number. Okay. So in the previous example we have just write it down this way, any non-perfect square. Okay, because that includes prime numbers. None is by non-perfect square. Can you guys give me an example of a non-perfect square? Like men, just the answers of the squares that are in decimal. Yes, very good, very good. Yes, very good. So under root 2, under root 7, and all these numbers. Okay, so they are irrational numbers. So this pi and this, they are very common examples. You see such questions in past papers as well, that in MCQs they ask you such questions, and you have pi and under root n, where n is a non-perfect square such number, so you should know that pi and under root 2, under root 3, under root 7, all these are irrational numbers, right? Every non-terminating number is a irrational number. Okay, and when we talk about rational numbers we have things very Clear, it would be terminating, it would be of this type 0.675. Or it would be in a fraction form, or it would be recurring, so you know that. Clearly that which is a rational number and which is an irrational number, right? So is everything clear for today? Yes, any questions, anything which you guys would like to ask again? Kindly could you explain this non-perfect square, like it could be in points and also in like whole number? Okay, I'll tell you. By non-perfect square I mean in maths we have. Let's talk about perfect squares. Okay, 1 into 1 is 1. 2 into 2 is 4, 3 into 3 is 9. 4 into 4 is 16. Okay, so I know that all these are perfect squares. By perfect square I mean when I do under root 16 I get 4, when I do under root 9 I get 3. Are you clear so far? Yes ma'am. Okay. But whenever you do, let's say under root 8 or under root 2, since 8 and 2 are non-perfect squares, for 8 there is no such number. When you multiply it with itself and you get 8. Like in case of 16. 4 is the number. When you do 4 into 4 you get 16, but when we talk about 8 there's no such number, that when you square it or when you multiply it with cell you get 8. So 8 is a non-perfect square, right? So is it clear now? Yes ma'am. Okay, now it obviously means if you're doing under root 16 you will get 4, if you're doing under root 9 you will get 3, but if you're doing under root 8 under root 2 you can check that on calculator, you will get a big number which is not being displayed fully because of the limit of our calculators. But in general, as a rule, just know whenever you have such a thing in under root you will get an answer, right? You will get a whole number because these are perfect squares. We are getting them by squaring two numbers. Okay, by squaring a number by multiplying the number with itself. But all these all the numbers other than these, like 8, like 2, like 3, like 7, they are non-perfect squares. So under root 8, under root 2, under root 7 would be a long non-terminating decimal number. This is why it is an irrational number, right? Yes ma'am. Is it clear? 100. Yes ma'am. Are you sure? Yes. Okay, so no questions? No. Alright, so I'll end the session. Okay, take care. I love this. Oh, give me my laughs. I love this.